Somewhere out there in the Atlantic, although this is actually the English Channel, but let's imagine for a moment it's the Atlantic Ocean. The nearest landfall is thousands of miles away in North America. Okay, got that? So somewhere out there in the Atlantic Ocean, there's a current that brings warmth from the southern hemisphere, and it brings it to the north. It gives Europe mild winters and enables Europe to have agriculture that's able to support the hundreds of millions of people who live there. This current is called the AMOC, the Atlantic Meridional Overturning Circulation. It's been slowing down for the last 70 years due to climate change, and there are concerns it might be about to stop altogether. If it does, the impacts will be devastating all over the world. The AMOC stopping would have catastrophic consequences around the world, severely disrupting the rains that billions of people depend on for food in India, South America and West Africa, increasing storms and lowering temperatures in Europe, and pushing up sea levels off eastern North America. It would also further endanger the Amazon rainforest and the Antarctic ice sheet. So in this video, we're going to try and understand how and why the AMOC might stop, how soon it will stop, sooner than you think, and the impacts that will come from it. First of all though, you need to become experts in ocean currents, and you need to have a look at this diagram. It shows the ocean currents that are part of the thermohaline system. Thermo means they're driven by warmth, differences in warmth, and haline means they're driven by differences in salt concentration. They go all over the world. The currents that are shown as red are those that are travelling on the surface, and those in blue are travelling down at the depths. There's the AMOC. It travels north in the Atlantic on the surface, so it's in red. When it gets to the Norwegian Sea and parts of the Labrador Sea, but we'll just say the Norwegian Sea, when it gets to the Norwegian Sea, it sinks down, or at least the seas there sink down, and the AMOC returns, and it returns in the depths up to 4,000 meters deep in that blue current that's shown in the diagram. And it sinks down there because as it's travelling north, it goes through the tropics, it experiences evaporation. The evaporating water leaves behind the salt, so it makes the AMOC current more salty than the other parts of the oceans. When it gets to the Norwegian Sea, that part of the ocean is much more salty, as the scientists say, has higher salinity. That part of the ocean is much more salty because the AMOC has been bringing its salt from the evaporation. Also, at that place, the winds blow across the Greenland ice sheet and the Arctic sea ice, and that cools the seas in that area, and it's that warmth that comes to Europe, which is very much appreciated. Salt water is more dense than fresh water. Cold water is more dense than warm water. So it sinks down, and if you look at this diagram again, it's the only part of the world where the water sinks down. Other places, the water wells up and the thermohaline circulation wells up to the surface. But in the Norwegian Sea is the only place where the water sinks down. And it only does that because of these unique situation in North Atlantic. To understand how special it is, we ought to compare it to the Pacific Ocean. And the Pacific is much less salty than the Atlantic. And that means no matter how cold the water gets in the Pacific, it will never be dense enough to sink down thousands of meters. The best you could hope for is it could sink down a few hundred meters. And that's a problem for the Pacific because there's no sort of overturning circulation. The water on the surface heats up from the warmth of the sun, and it expands and it gets lighter, and so it just sits on top of the rest of the water. So the scientists say that's stratified. I think stratified, something like that. 20% of our civilization CO2 emissions are absorbed each year by the oceans. In the Pacific though, because the water is stratified, all the surface water is saturated with CO2. It's starting to get to a point where it can't absorb any more CO2, and in some places of the Pacific, CO2 is emitted by the Pacific Ocean. The Pacific Ocean has so little salt in it that for each litre of water in the Pacific Ocean, it contains 1 less gram of salt. It's less dense compared to the Atlantic Ocean by 1 gram of salt. Well, a litre of water weighs 1 kilogram, 1,000 grams. So, by being 1 gram less dense than the Atlantic Ocean on average, the Pacific Ocean is 0.1% less dense. And it makes this massive difference. So, Pacific Ocean, 0.1% less dense, no overtoning circulation. Atlantic Ocean, well, by the time the AMOC gets to the Norwegian Sea, that part of the sea has so much salt in it, it's 0.3% more dense than the water in the rest of the Atlantic. That really is so finely balanced. So when the AMOC is slowing down, it's slowing down because that part of the ocean, the Norwegian Sea and the Labrador Sea, are starting to contain less salt, and it's because the Greenland ice sheet is melting. It's full of fresh water. The fresh water enters that part of the ocean. It makes it less dense, and the scientists know this because they measure the amount of water the Greenland ice sheet loses every year using satellites, so they can do it quite accurately. And they can see the more water the Greenland ice sheet loses, the slower the AMOC travels. And in years where the Greenland ice sheet doesn't lose quite so much fresh water, the AMOC speeds up again. So it's fairly well understood. Well, so far, the AMOC in the last 70 years has slowed down by 15%, 15%. But scientists think it might stop altogether by possibly as soon as the 2057. And you might think, well, how is it? It's taken 70 years to slow down 15%. How is it going to suddenly stop altogether? It's because the AMOC is a system that is said to have a tipping point. And an Earth system is said to have a tipping point if as climate change gradually increases, as the warm temperatures around the Earth gradually increase, a system like the AMOC is gradually affected by 15% over 70 years. But if it has a tipping point, it reaches a stage where the internal dynamics of its own physics take over, and it's much less affected by climate change. So, for example, that part of the ocean, the Atlantic Ocean, which is so salty, 0.3% more salty, 0.3% more dense, it's only got so much salt there because the AMOC brings the salt as it experiences evaporation, brings the salt to that area and those oceans where it sinks down to the sea in a process called convection by the scientists. As the AMOC slows down, it will bring less salt. As the Greenland ice sheet loses more water, that salt that is there will be more diluted. So, and the more diluted it gets, the slower the AMOC goes, so the less salt it gets. And every tipping point is important because it's self-amplifying. Every tipping point is self-amplifying. So even though you get a small change, it works out as being an exponential effect, exponential increase, which is exponentiality is the one thing all doomers are very concerned about. But we can seem to be quite safe now. Suddenly things will ramp up. What makes it even more interesting is the Greenland ice sheet has its own tipping point. Its tipping point is forecast to happen when there's 1.5 degrees Celsius of warming. Well, at the moment, officially we're at 1.2 degrees Celsius. The Greenland ice sheet could reach its tipping point now. In the next few decades it reaches tipping point. And again, as the Greenland ice sheet melts, it will gradually lose a bit more water as the temperatures rise. Sooner or later, it will just collapse. You won't need a satellite to monitor how much water it loses each year. It'll just be huge mountains of ice will slide into the Atlantic, lubricated by their own meltwater. It's happened before, and we're going to find out about it later on in the video. So you've got two tipping points there, interacting with each other, the AMOC and the Greenland ice sheet, which makes it quite difficult for scientists to predict. So we've known for 60 years this could be a problem. Somebody made a Hollywood movie about it. It's only now, as we get closer to it, it becomes more obvious what a problem it is. The The good thing though about the AMOC, it doesn't just interact with the Greenland ice sheet. Here's a list of all the Earth systems around the world that have their own tipping points that the AMOC interacts with. So the AMOC affects these systems and is affected by these Earth systems. So we've got the Greenland ice sheet, which we know already, which is due to reach its tipping point at 1.5 degrees Celsius. The West Antarctic ice sheet, again a tipping point of 1.5 degrees Celsius. And if you look back at our diagram of the thermohaline circulation around the globe, where the AMOC starts off is by the West Antarctic ice sheet. And in fact, looking at the diagram, everyone always says, look at all that warm water coming from the Pacific. But really, 75% of that water entering the AMOC comes from around the Antarctic, which is losing ice, which is making the AMOC already less salty because the ice melt is diluting any salt that's already in the AMOC. So that's something people don't realise. The AMOC is already being compromised at its very beginning. And the Greenland ice sheet and the West Antarctic ice sheet affect each other. The AMOC affects and is affected by Arctic sea ice. Permafrost could be affected by the AMOC at 1.5 degrees Celsius. The Amazon rainforest at 2.75 degrees Celsius. ENSO, the El Nino Southern Oscillation, because as the AMOC slows down, it will bring less warmth to the northern hemisphere. That part of the Pacific where the Walker circulation takes place, which is a current that helps to power El Nino, that will therefore get more heat, be more powerful. So it'll affect the El Nino. Some people are beginning to wonder, is the El Nino so powerful recently, and we're not quite sure why? Is that something to do with the AMOC slowing down? Anyway, that's just my own conspiracy theory I thought I'd introduce. Which will also affect the West Antarctic ice sheet, which will also affect coral reefs, and a combination of the AMOC stopping and a more powerful El Nino La Nina cycle will affect monsoons in West Africa and India and all around the world. It will affect what parts of the United States are still able to have agriculture. Plus, what is probably one of the most important tipping points when it comes to working out when the AMOC might stop is what's called the subpolar gyre. It's like a bit of a whirlpool. It works in the Labrador Sea. It's due to stop at 1.8 degrees Celsius of warming. No one ever thinks about it. The models don't take into account tipping points from other systems normally. They definitely don't take into account this one, so that could be a real problem. Can you imagine what it's like being a climate scientist? You've got to develop a model that can, first of all, it's difficult to predict tipping points. Secondly, it's even more difficult to predict tipping points when there's all these different systems interacting with each other. If you see the normal graph the United Nations publishes and it says this is the rate of warming we should have to the year 2100, excuse me a minute, there's an enormous container ship going past. Anyway, the United Nations publishes a graph and it shows up to the year 2100 maybe we're on track to have 3 degrees Celsius of warming, and it's a nice smooth graph. You think, well, how can we have all these tipping points and they only have this smooth graph? Well, because they don't necessarily take into account tipping points, and instead, as we'll see later on, they just add a paragraph on the end saying this might be a bit quicker if things tip. With all those systems affecting each other and they're all having tipping points, it's not likely, but it is possible that we could have a worldwide tipping point cascade. It's not likely, but it is theoretically possible. If the AMOC does stop, there's no way of restarting it. In the past, the AMOC has been stopped by too much rainwater just off Greenland, which diluted the salt concentrations. Also, in the past, when there was too much ice on the sea, that stopped the AMOC. And sometimes people say, well, if AMOC brings warmth to the northern hemisphere, as it slows down, it will bring less warmth, so that part of the sea will become colder and the water become more dense and sink down. That won't happen though, because as we know, it's the salt that really makes it dense enough. So the water in the Pacific, no matter how cold it gets, it will never dive down, and that's what stopped the AMOC before. So it stopped twice before the AMOC. at least twice before in 2 different circumstances. It won't happen now though, because scientists believe it's travelling so slowly now. Maybe it goes about 1 or 2 centimetres a second. It's so slowly, it's in a state where once it stops, once the concentration of salt gets so low, even if you started adding the salt back in somehow, or reducing the melt from the Greenland ice sheet, it wouldn't get going again. But it wouldn't have that momentum. One of the reasons it's only recently it started to dawn on everyone what danger we're in is because the models find it quite difficult to model in enough detail of what's really going on. Here's something from the latest United Nations Intergovernmental Panel on Climate Change report. The Atlantic Meridional Overturning Circulation, AMOC, will very likely decline over the 21st century for all scenarios. There is medium confidence that the decline will not involve an abrupt collapse before the year 2100. That's because the United Nations thinks we're heading possibly to 3 degrees Celsius warming at the moment by the year 2100. The AMOC's central point of its estimate of when it will stop altogether is at 4 degrees Celsius, so they're hoping it won't stop for at least the next 75 years. But if you find out how devastating a stop would be, the fact it's not going to happen for 75 years is little comfort. And now they go on to say just how poorly the models do at understanding what's happening. For the 20th century, there is low confidence in reconstructed and modelled AMOC changes because of their low agreement in quantitative trends. So the models aren't even able to recreate the past. The low confidence also arises from new observations that indicate missing key processes in both models and measurements used for formulating proxies, and from new evaluations of modelled AMOC variability. That means they don't really understand how the AMOC works in enough detail to feel they've got a good understanding about it. Because they don't understand when the Greenland ice sheet might tip or anything like that, they just add a paragraph on to sort of cover themselves, to say the models don't know what's going on. We think we're okay for 75 years, but it could be worse if the Greenland ice sheet collapses. In addition, fresh water from the melting of the Greenland ice sheet could further enhance the future weakening of the AMOC in the 21st century. That's where we are now, the 21st century. So if the climate models can't help us understand when or how the AMOC might stop, we can get a good idea from paleoscience by using geology and fossil records and ice cores to understand what's happened tens of thousands or even hundreds of thousands of years ago. Here's something from one report that explains what could be about to happen. Deep sea sediment cores and holes were drilled into the Greenland ice cap. These data reveal that climate changed frequently and in great leaps rather than smoothly and gradually. We think we've got smooth warming ahead of us. This report, based on the paleoscience, looking back thousands of years, seems to show the climate is going to change in great leaps, is going to change frequently, and what is going to cause it to do that? Given the regional patterns of these changes, he identified the AMOC as the culprit. And what was it he found that disturbed him so much? More than 20 events prominently show as abrupt warming spikes of 10 to 15 degrees Celsius within a decade or two in Greenland ice core data. And now we get to the most interesting bit, I think. Oh, hello. Hello. Little dog. That's all right. Now we get to the most impressive part of this, I think. The great iceberg armadas. Iceberg armadas drifted out across the Atlantic, leaving behind telltale layers of ice-rafted debris on the ocean floor and adding fresh meltwater to the ocean surface. This led to even more dramatic changes linked to the complete breakdown of the AMOC. So much ice entered the ocean that sea levels rose by several metres. Can the Greenland ice sheet really contain so much fresh water that it could stop this entire global circuit of ocean currents? All that has to happen is it needs to lose water quickly enough to saturate that part of the ocean by the Norwegian Sea. If enough water is lost quickly enough, that would be enough to stop it. So scientists say the rate at which the Greenland ice sheet melts is in some ways more important than the fact it's all going to melt. The reason people are saying the AMOC could be reaching like the end chapter, it could be about to tip any moment, is because people are comparing how the AMOC is working now with how it worked in the past. They say it's probably about the weakest it's been for 1,000 years. And what's more troubling is they check what's called the AMOC's variance and autocorrelation. And the variance is how much the speed changes, because there's always natural variation with the ocean currents. And they compare it to patterns of how it's performed in the past. These are the sorts of things that scientists are spotting. Classical early warning indicators, such as the increase in the variance and or autocorrelation, suggest the present-day AMOC approaches a tipping point before the end of the century. It seems almost inevitable that the AMOC will stop, sooner rather than later, but when will it stop? Officially, its most likely time of stopping is when we have 4 degrees Celsius of warming. Scientists are now thinking it could be more like 2 or 2.5 degrees Celsius. We estimate a collapse of the AMOC to occur around mid-century under the current scenario of future emissions. So 2.5 degrees Celsius of warming, that's around about 2060. Committed loss of the Greenland ice sheet is more likely than not to occur beyond 2 degrees Celsius of warming, and the United Nations report, published by the Intergovernmental Panel on Climate Change, thinks when we get to 2 degrees Celsius of warming, we will just be in a world of tipping points. With the IPCC expressing medium confidence regarding long-term near collapse of the loss of the Greenland ice sheet for sustained warming of 3 degrees Celsius or more. 3 degrees Celsius or more, that's the year 2100. The report published by the Organisation of Economic Cooperation and Development, which is made up of just about all the governments from the global north, they published a report that says what the impacts will be, and they expect that to happen if we had 2.5 degrees Celsius of warming. And now I'm going to read out the impacts. But before I do that, have you noticed something about this video? Not that the AMOC's about to stop and there's going to be a worldwide catastrophe, but how the scientists just accept it. I've just been saying the Greenland ice sheet will collapse 1.5 degrees Celsius in the next decades. That will raise sea levels by 7 meters. The AMOC will stop. It's not like headline news, is it? It's public. I just get this off the internet. It's in the public domain. We just accept it now, don't we? At one time, saying the Greenland ice sheet was lost cause, staying below 1.5 degrees Celsius of warming was a lost cause. You'd be condemned as a doomer, wouldn't you? As a negative. That gradual loss of hope takes the sting out of losing the fight, doesn't it? If the AMOC stopped altogether, then Europe would end up being between 3 and 8 degrees Celsius cooler on average, and North America between 1 and 3 degrees Celsius cooler. It sounds a lot. It would change at a rate of 1 degree Celsius every decade. So every decade you get 1 degree Celsius colder. If you compare that to the rate of global warming we've had for the last 200 years, where temperatures have risen by 1.2 degrees Celsius, well, the first decade, that'd be quite good, because that would reverse 200 years of climate change. After that, it'll start to get cold. I can give you an example of what it means, though, by comparing London with Calgary in Canada. London, England, and Calgary, Canada, are both at the same latitude. At the moment, in the wintertime, in January, the average maximum temperature in London is 8 degrees Celsius, and the average minimum is 3 degrees Celsius. They're both above freezing. In Calgary, the average maximum they expect in January is minus 2 degrees Celsius, and the average minimum is minus 12 degrees Celsius. Well, in Britain, I had a heat pump installed last year, and when they design your heat pump system, they design it on the understanding that the coldest it could possibly ever be will be minus 2 degrees Celsius. That could be in the future, like the best you could hope for, minus 2 degrees Celsius. It would take 80 years to get there, wouldn't it? At 1 degree Celsius every decade to reduce 8 degrees Celsius. It would take pretty much 80 years. Say the AMOC doesn't stop for 20 years, that's 100 years time. So you, in theory, you could adapt it, couldn't you? You could put better heating systems in and buy more snow plows and things like that. What's more serious though is the changes to the rainfall. In London in January they get on average 12 days of rain. In Calgary they only get 3. The thing that really will be a disaster will be the changes in rainfall. And unlike the heat, which might take nearly a century to gradually change, it would happen almost instantly. And in fact, the AMOC is said to have a fast tipping point in there. As soon as it stops, you start to feel the impacts. The Greenland ice sheet could reach the tipping point. We might not notice, you know. We just think, oh, it's losing a bit more water. So now I shall read out the impacts. Profound and abrupt shifts in regional weather patterns and water cycles. Southward shift in tropical rain belt with strengthening of monsoons in the southern hemisphere. Widespread cooling across the northern hemisphere. In the southern hemisphere, there is little temperature change, but strong disruptions to precipitation patterns in the tropics, corresponding to a southward shift of the intertropical convergence zone. Widespread drying across Europe and Asia. Increases in precipitation in North America. This would cause dieback in the boreal forests in northern Europe and Asia. Each year, land-based vegetation, like the boreal forests in the northern latitudes, they absorb each year 30% of humans' CO2 emissions. So the oceans absorb 20%, more or less. The forests and the vegetation absorb 30%. Do you know how much CO2, how much they took out of the atmosphere overall last year? Almost nothing. It's really serious. Is it a one-off? Have the forests reached a tipping point? Nobody knows. Next year we shall find out. Then we get more changes to the rain. Tropical rain belt shift would cause a substantial reduction in rainfall over northern South America. Have you noticed northern South America is already being affected? As the AMOC gradually slows down, you don't have to wait for a tipping point to see these things happen, but they will just gradually start happening anyway. And an increase in rainfall over the proportion of the Amazon located in the southern hemisphere, as well as over northeastern Brazil, which is directly affected by the tropical rain belt. So maybe that's good news for the Amazon. Maybe it's going to get more rain. So you're thinking, well, this is very interesting, count everything, but I should just buy an umbrella or something. No, this is where we get to the exciting bit. It turns out that agriculture relies on rainfall all over the world. Profound impacts on agriculture globally, leading to a critical threat to global food security, a critical threat to all food all the way around the world. Reductions in the growth suitability of 3 major staple crops, wheat, maize and rice, which provide over 50% of the global calories. Most of the northern hemisphere will become less suitable for growing these staple crops, but Europe would especially be affected. There are hundreds of millions of people who live in Europe and they like eating food. An AMOC collapse would thus increase seasonality, reducing agriculture productivity with colder winters and drier summers. In Great Britain, there'd be widespread loss of arable land by 2080 because of climate drying. Sea level rise along North America would occur. You have to wait 100 years to feel the temperature change because of the changes in the weather patterns, in the rain patterns. 2080, where are we now? 55 years away, which is a shame. After all making these videos, I'd like to know where we're going to end up. And then we go, West Africa will experience the largest decreases, causing widespread drought over much of the region due to weakening of the monsoon. Rainfall in India halved due to weakening of the Indian summer monsoon, leading to more frequent droughts with detrimental impacts on Indian farmers' rice harvests. It's not that the AMOC is Earth's point of no return. It's really the point of no return for human civilization all over the world. And remember, once the Greenland ice sheet has reached its tipping point at 1.5 degrees Celsius warming in the next few decades, there'll be no going back. It's reached its tipping point. No matter what we do to our carbon emissions, or anything that humans do, the internal dynamics of the physics of the Greenland ice sheet will overtake any effects that come from the general increase in global warming. So in the next couple of decades, it could just become impossible to do anything about it. We can see it coming, we can't do anything about it. And because it happens so quickly, because we know so little about it, the AMOC might stop before we realise. We maybe will get a year's notice, maybe we won't, maybe we'll just realise afterwards, when the scientists realise temperatures in the north are cooling and in the south are rising. When people realise that El Nino has become mysteriously very powerful, when sea temperatures seem to be mysteriously high and we can't really explain it. There are people all over this beach. It seems unkind to tell them, really, doesn't it? That's the end of the video, really. I can't think of anything inspiring to say this time. At least I've had a nice day out by the seaside. So thank you for watching. Feel free to leave a comment. The weather's been so bad recently, I'm going to start making videos inside because, you know, the rain makes it very difficult to get out and do these films. So anyway, thank you for watching, and I'll see you next time.